This is Jared from Commit Quality, and in today's video we're going to go over types in C#. If you watched my last video, you should remember that we talked a little bit about this type of string, which is a special keyword. But let's go into types a little bit more. So because C# is considered a strongly typed language, variables have a type specified to them. When we are defining a variable, which is what this string YouTube name is going to be, it'll make sure that the data stored inside that variable matches the type it should be. As we carry on with this series, you're going to see that we don't just use types in variables. We use them when we want to return items from methods that may also return a type too, and many more things. What I want to do is I'm actually going to delete everything we've done in the first video here, and tell you what, we'll get rid of that comment as well. And I want to talk first about primitive types we have. So in C#, we have a bunch of primitive types like booleans, integers, floats, decimals, chars, and that's what we're going to cover right now, and then we'll go into implicit types as well. So enough talking for now. Let's actually go through what I'm talking about. So a boolean is a true or false value. So I can say boolean, have you liked the video? So I'm going to say liked equals true. That means liked should be set to true. Now what I can't do is say put a string in here and say true, because like we just said, C# is going to check that the variable we've created has the correct type. And like I said, with a boolean, you can only have true or false, whereas right now we've passed through true as a string, because if I hover over, you can see here it's of class system.string. So it's really good at basically telling us what we need to do or when we've done something wrong. Like say you've got true or false value here, but of course you've liked the video, so let's keep that to true. The next I want to talk about is how we kind of handle numbers. So I can say an integer and we'll say subscribers. So how many subscribers do I have? So let's say 2,500, which I'll hopefully get to by the time we actually produce this video. And the int keyword here represents a 32-bit signed integer, so it does have a max limit as well. But typically you're going to see, if you're seeing numbers like this, you're going to store them as integers. Now, there's other ways as well. So what if we wanted to store kind of decimals or floating point numbers? Well, we can do that. We have a type for this. We have float. So let's say float of, let's just say money, and we can say equals 20.22. Now, what you'll notice, as I close this off, it's complaining because with a float, you need to use the suffix of f after it to say this is a floating point number. So that'll work completely fine. Now we can also say double as well. We'll say money as double, which can also hold the same value. Or typically what I use the most of is decimals, and that's because decimal will have the highest precision. Once again, you can just take this. I'll say decimal, money as decimal, because you have to change the names, and I can say 20.22, but similar to float, to mark it as a decimal, if I hover over it, you'll see here that we need to use a suffix of m at the end of whatever we set in the value to. So here we are. You can use multiple of these. You can play around. Like I say, as we go through videos, you'll probably see us using different versions, but typically I'm using decimal. In the last video, we kind of talked about strings, which we're not going to cover yet in this video, but we can also say, maybe I don't want a string, maybe I just want a single character. Well, we can do that. We can say char, let's just say letter, equals, and whatever we want. Let's say f for whatever reason. What you'll notice is it's surrounded inside single quotations here, not marked as what a string would be, which is this. So you have to pay attention what quotations you're using around them, because this is going to throw up an error because it thinks that double quotes stands for the string. So make sure you have single quotes around it and whatever the character would be. These are some of the core basic primitive types that you're going to see used throughout the video. We will definitely be digging into more things and things we can do with these as we go through videos as well. But also want to touch on other types like reference types. So we talked about strings, okay? So if I said string name equals commit quality, although a string is not a primitive type, it's a reference type. And I really wanted to touch on this as part of this video, as we're going to be using it a lot. A string is basically a list of characters, like we touched on in our previous video. And it's worth noting a string can contain anything inside its double quotes. or it can be completely empty. So I can say commit quality. I could say 121, this really long number that I just bashed on the keyboard, and you'll see there's nothing kicking up. Unlike if I was doing into quotations, you'll see it will cause an error, and that's because now this integer isn't actually being taken as integer, it thinks it's a string. So you can actually put whatever you want, and I touched on as well, it can be completely empty, right? So you could do string equals empty double quotes, and that would return fine. Or even we can say string dot empty, and that would be completely fine. All this would do behind the scenes is set string name equals, and it just look like an empty string. But let's put this back to commit quality. There's so many things we can do with strings as well, and I think it warrants its own video, but something I wanted to add into this kind of type discussion. Now, the next thing I want to touch on is how these variables can be changed as well. So you can say string name equals commit quality, but then you can go underneath and say name equals Jared, which is my real name. Nothing wrong with that. And if I was to do a console.writeLine and say name, what's going to happen is straight away, name will be set to commit quality, and then down below, I'm rewriting that to be Jared. So if I run my program, we're expecting to see Jared is output. Now, what if I put console.writeLine here, and I put 1 here? Well, what happens then is it reads the initial value of commit quality. Somewhere later on in my program, I decide, oh, I don't want to be called commit quality. I want to be called Jared. Well, the console then will take that new assignment and output the new value. So what we should see first is an output of commit quality and then an output of Jared. So that all works completely fine, no problems at all. But in some cases, we might not want the variable to change. Maybe we want it to stay static, and that's what we can use consts for. So I can say const string, let's say greeting. I will say hello, because we should never want to say hello in any other way. Of course, in reality, we can say hi, hello, whatever, but let's just take it that we've decided our users can never say anything other than hello as a greeting. Of course, this is a string type, but you've seen this new keyword here called const. And what this is doing is ensuring safety of a variable never changing. If we try to change a const, we're going to be hit with a compiler error saying it can't be changed. So we saw we could change name completely fine. But now if I tried saying greeting equals hi instead, if I try to actually execute this, you'll see there's build errors. If I say no and go to the error list down below, you've got here the left-hand side of an assignment must be a variable property or index, because it's not understanding the greeting can be changed because const, because we've marked it as a const there. If I was to get rid of this, you can see the error goes away and we run and it runs completely fine. Of course, we haven't actually output anything into our console because we haven't had a console.writeLine, but definitely very useful when you want to ensure safety that something does not get changed. It's definitely something I'll work into future videos so we can kind of cement where we want to use the const keyword. Let's just clear everything down for a moment then, and I want to touch on variables. So there's a few things with variables I think that's very important. So once a variable is declared, it cannot change its type. For example, we can't change an integer. So if I say int x, or let's say int age equals 55, I'm not really 55 by the way, but if I say int age 55, I could say age then equals 22, and we saw this with strings, that'll work completely fine. But what I can't do is say I want to change this to a Boolean type, because then the type safety of C# just goes out the window and it wouldn't make sense, because we originally say it's an integer and now we say let's try and convert it. But there are a few different ways to change type, which I'll go over now then. So let's just use numbers for a moment, and we'll keep age to what it is. What I can say is I want to do an implicit conversion, and what that means is I have an integer here, but I want to convert it into a long type, and I'll call it long age equals age equals age. Now this will work completely fine because longs can contain integers, but also it's a way to store larger numbers. So where we said integer has a max value, a long is a 64-bit signed integer, which means it can hold integers and values higher than integers as well. Just to prove it, if I say console.writeLine, and I'll say age first of all, and then I'll do the same thing. I'll do console.writeLine of long age. So what I've basically done here is an implicit conversion to a new variable called long age, which basically still takes the integer value of 55 because a long can contain that. If I run this, there we are. We've got both 50 files with no compiler error. So that was implicit typing. But now then, let's get rid of this and let's do a cast, or also known as explicit. So I'm going to say decimal number equals 100.0m, which is just a decimal, as we talked about at the start of the video. What I want to do now is cast this to an integer. So what I can say is, let's create a new variable called num as I, because that's a number integer, and then I'm going to open up brackets and say int, and there we are. It was telling us what we could put in of number. And what we've said here is, I want to take the decimal of 100.0 and convert this into an integer with this cast of number. So we should see that if I do a console.writeLine here, we should see 100.0 output, and then I've casted that decimal into an integer. So if I say output num I, we're expecting then to see a console write-line statement in our console, which is just going to output 100 without any decimal points. So if I say run this, here we are, you've got your decimal, and then we've casted the value of this decimal into an integer. Let's show you what happens if I didn't cast it. So if I get rid of the brackets with int here, save and run, you can see we have a build error. And here it says cannot implicitly convert type, which is what we did in that first example, to a decimal, type decimal to an integer. An explicit conversion exists, and it's asking us, are we missing the cast? And yes, we were, because that is how we perform these explicit conversions. So there is another way called parsing as well. And I'm going to cover parsing in more detail when we go into depth about strings, but I do want to provide a basic example. So let's say string subcount equals console.readline. Now, if you remember what this did, this is going to allow the user to enter something into the console, and we're going to store that into this subcount variable. It has to be a string because even though we're asking the user to enter a digit, if I say int, this will cause problems because it's expecting a string to be returned. So here I'm going to say string equals subcount. Then what I want to do is I want to say int goal. So what's my goal? What would I really like to achieve? So I would really like 10,000 subscribers. And I say take that away from subcount. And then we're going to write console.writeLine. You have, let's say, goal, more subscribers to reach your goal. I'm going to have to add in some spaces or it's all going to look muddled together. So what I've said is I want to get the sub count, so I'm going to say enter in 2000. It's then going to do a calculation, say int goal equals 10,000 take away whatever I've entered, 2000. So then the output of the console should say you have 8,000 more subscribers to reach your goal. And of course, don't forget to end your statement with the semicolon. What you might see now is if you have your error list up, or if you've seen this, we have a red squiggly line. And here, it's telling us what the problem is. Operator minus cannot be applied to operands of type int and string. So it's basically telling me I have a type of int here and a type of string here. I can't run my program because we've got errors. So the way to get around this I'd have to pass this string into an integer. So how we can do this is by saying int subs equals int dot pass, and I can pass through the sub count here. So what we've done now is we've taken this sub count string type, created a new variable or a new identifier called subs, and we've passed the string into an integer. So if I replace sub count with subs, we can see the errors go away, and we should see this works as expected. So we used the example of 2000. Of course, to make this bit readable, you could have put a console.writeline, but we know what this is doing. So I'm going to say enter 2000, because I have 2,000 subscribers. And this tells me now I've got 8,000 more subscribers to reach the goal of what I want to achieve. Now, you might be asking, what happens if I didn't enter a number here and I entered a string? Well, this pass is going to fail. And there's other ways around doing this. So we have like a try pass method, and that's going to check if it can be passed or not. I'm going to cover that off in more detail in a future video, because we're getting off the topic of kind of variables and types as well. And before we sign off, there's only one last thing I really wanted to cover, which is what we can actually have a variable stored as. So they are case sensitive. So I could say sub count here of 200. And I could also have another variable called sub count with no capital C here of 200. And look, there's no errors with it. It's telling us that this not being used, but there's no errors because they are case sensitive. So I could say sub count. I could have multiple of these, and they'll all act as different variables. So you want to be careful that you're naming your variables in the right way. I believe I covered this off earlier anyway, but it's also remember that names of a variable can begin with a letter or underscore, and it can't start with anything else. So I couldn't say to sub because it starts with a 2, but what I could say is underscore sub, and that would work completely fine. Awesome. So that's covering off the basics of types, the basics of variables. Like I say, we're going to be using these different types, and we'll be definitely using variables in the future videos. But as always, if you do have any questions or comments, please drop them down below. Thank you for watching. Have a good day.